the RSSC Robotics Society of Southern California, along with the Riverside Robotics Society, and a third club from the San Bernardino. So welcome all, and today's speaker, or today's speak from Alan, is going to be about the migration, right? Is it still migration from one platform to an upgraded version, and in this case ROS 1 to ROS 2, and Alan's going to talk about his experience and some generalizations, I guess, as well, and some specifics about that, so the people that don't know a lot about ROS won't get completely bored. Anyway, take it over, Alan.
Yep, for sure. As is usually the case, I'm always happy to talk about whatever the heck I've been working on for the past month. And I had actually mothballed the Todd project for a couple of months, and then someone came along and asked me for the part files and started printing them out, and it got me all excited about it again. So as part of that, instead of making it do anything useful or finish the code, hey, how much fun it would be to port the framework from ROS 1 to ROS 2. So that's where this afternoon's talk came from. The other thing coming up is that with Dr. Bruce taking a break from lecturing for a little bit, we're going to switch up the format a little bit. We still want to keep the cadence of a meeting every 2 weeks, but learning from our HBRC and our DPRG friends, we'd like to have one meeting scheduled with an actual talk of whatever someone's working on to take up a half hour, 45 minutes, etc. And we'd like to use the second talk of the month and the fourth week, or the second meeting, as a kind of a free-for-all, share what you got open session. So it seems to work fairly well for the other clubs that have done it, and I'm excited to give it a shot. We'll send out, it'll be the exact same meeting link. It's the same cadence of second and fourth Saturday. As is always the case, if you're working on something cool and are comfortable speaking about it for a few minutes, let us know, let Jim know, or Ben know, or myself, or Walter. And we would be happy to put you on the schedule to give you enough time to fully share the exciting stuff that you're working on. It's funny, we keep joking about it, but it's 100% true. Most of us, myself included, aren't super excited about getting in front of people and being forced to talk about something. But once you get us started, oh man, it's hard to get us to shut up. So it's just a matter of getting a comfort level with that. And I'm hoping that the open sessions that we're scheduling in the second half of the month will help with that, to help us identify, call out, and encourage people who are doing, and you all are doing amazing things in your areas, to feel more comfortable taking up one of the half hour or the hour talk slots for a future month.
Yeah, thanks for covering that.
Yeah.
I forgot.
Yeah, we're good. Teamwork. All right, let me go ahead and share a portion of my screen. So I picked up something new recently. So as all of us, we're all doing either Zoom or Teams or GoToMeeting or Cisco WebEx, right, to stay in touch with family, friends, to work in our case. And we're using Zoom, of course, to communicate tonight. And by default, when you share a screen in Zoom, it shares the entire application window, right? And you're like, oh, yay, just show whatever you got. However, if you have an odd format screen, or in this case, ridiculously huge 4K screen, that isn't really as practical. I'm sure the writing's super small, tiny, and it's impossible to see anything. You may have noticed that I have my screen divided into 3 quadrants. I've got notes down below. And really the part that I want to share with you is up in this corner. One of the things that I learned recently was when you're sharing a screen in Zoom, you can share the entire screen, which I just subjected you to. You can share an individual window, which is great as long as you don't have to switch back and forth between one window and another. But you can also share a portion of the screen. So what I'm going to do is I'm going to set up a little frame for this corner right here. and I'm going to try to do all my presentation here. So I may have slightly overthought my talk tonight. I'm not sure if I'll have too many slides or not enough. But what I want to share with you tonight is, and I hate to blow the ending for it, but I'm not sure yet. You're going to help me decide. Is that if it's time for you as an individual or me in terms of the Todd project to move over to ROS 2. And I know people have me pegged as being a ROS evangelist, and and all you have is a hammer, everything looks like a nail. But the truth of the matter is, I'm all for using whatever framework works for your application. And there's a large number of things that we solve for today that an Arduino is just fine, or an ESP32. Further up on a Raspberry Pi, for people that are comfortable coding their own communication infrastructure, or just want to grab the OpenCV sources and write their own program. That's all totally okay. So just to make sure we're talking apples to apples, I just want to really quickly switch over to a couple of common frameworks. And now for those of us in the group that are still working on Arduino, I'm going to call Arduino a framework, and I'll show you why in just a second. Some more of us are really familiar, and we like Easy Robot. Thomas is one of those. Up until recently, we had several members that were doing RoboRealm, which is a framework for solving for machine vision. So a higher level API or series of functions to put the tools to do fun things in your hands. And of course, what we're talking about tonight is ROS. ROS is split into 2 different versions right now. For a while, ROS 2 was the great unicorn. Everyone talked about it, but no one had seen it. And then all of a sudden it was here, and people are developing against it, and it's becoming more stable. So I should have looked this up. Let's just say 10 years. ROS 1 has been for about 10 years through Willow Garage. It was written specifically to solve for the PR2 robot, that super awesome multi-$100,000 robot that they gave away 10 or 15 of before they folded. And ROS 2 is a continuation of that. It's not the next version. When I first approached it, I treated it like, oh, this is just the next version of ROS 1. And I kept getting stuck because it's not. It is related. It solves many of the same problems and solves new sets of problems that ROS never even took into account. But it's best to approach it as a new framework and not as an extension or a new version of the ROS framework. So I'll just spend another minute on this. When I call Arduino a framework, let me show you what I'm talking about. We have a lot of Arduino coders, which is super great. And let me bring up one of the examples here. So this is from the example set 1, how to read in an analog value. So the Arduino IDE, if you want to call it an IDE, inside joke, it has a series of functions and tutorials, and you write C code. There's a setup loop, a setup function and a loop function. And as part of this very basic introduction, there's this function called analog read. I'm sure most of us have used it if we want to read in a potentiometer for a position or a sound or a light level. It's one function. You provide the pin number of the pin you want to read. You obey some rules for the minimum and maximum value based on how much voltage is being applied to the Arduino. And you get back, I believe it's a 12-bit number.
10-bit.
10-bit, thank you. 10-bit number for the range, telling you what the analog to digital conversion of that number is. And that's as far as most of us go on the Arduino side. It's a set of functions and libraries that make using the Arduino hardware easy, straightforward, more accessible. But this is an abstraction. It's actually a framework. When you write actual atmel-C against these chips, even though it's the C language, it looks nothing like this. And much like ROS and some other frameworks, when you purchase little additions and peripherals and stuff, sometimes they'll come with an Arduino library that you can load into your project and take advantage of those functions. So the rule that I've been saying for a while is, if you play by the rules of Arduino, you get to play with all the tools in the Arduino toolbox. And so that's what I mean when I call Arduino a framework. And for those of you who haven't looked yet, the moment you peek behind the door, you get to see what code is being generated by these abstractions. And it turns out, if you want to read the, the AVR Developer's Guide or Atmel, that there's actually quite a lot of steps to do a simple read of an analog value from one of the pins. And when you go into the sources, and I'm not going to drain this for you, this is just to, not even to scare you, but give you a little bit of understanding of Arduino as a framework. There's actually quite a lot that goes into setting up that microcontroller to be able to read that value, to make sense of that value, and then to close out that operation when you're done. So when I talk about frameworks, ROS isn't any more or less scary than Arduino in that it's an abstraction, a framework, an API to get you from point A to point B. And to use one of my sayings that you're going to hear a lot, this is my litmus test for any framework that you're looking at, whether you're coding ROS-C or Atmel-C or Arduino or Easy Robot, whatever it is. I'm not going to tell you to use ROS, but I will help you to evaluate if the approach that you're using solves more problems than it causes. And occasionally the answer is no. Perhaps, this is your excuse to dig into the intricacies of ROS. And so heck or high water, the purpose of the project is to learn ROS, and then that's totally okay. But when you're going to solve real world problems, there are some things that the ROS framework solves really well, even problems you didn't even know that you had, typically PC based. And there's lots of stuff that we do every day where an Arduino is just fine. So this will be one of my recurring themes throughout my talk this afternoon. Does it solve more problems than it causes? So I want to share with you my experiences evaluating the ROS2 framework for Todd, and then you can help me decide what direction I'm gonna go with it, if I'm gonna continue to develop the ROS1 framework, or I take the extra time to move over to ROS2. And like most things that are worth learning and knowing, the answer is not as simple as it sounds. So what does ROS2 have going for it? I tried to find an online list that succinctly identified the stuff that really is a benefit of ROS2, and for some reason I couldn't find it, so I just made one up. There's actually quite a lot, and the more I learn about it, this list will probably expand. Where ROS was developed specifically to solve the problems that they were running into when making that PR2 robot, and it did that excellently, and it ended up being a stable standard framework and API that thousands and thousands of people have provided additional modules for and tutorials. But there's a lot of stuff that it doesn't do great that's a little bit more important now than maybe it was that we realized when the PR2 was released. So this is my list of the things that I see as ROS being a benefit for, ROS2 being a benefit for over ROS1. For starters, security and quality of service is baked into the communication layer, meaning that you can say how you prioritize messages between back and forth. And in ROS1, if you're on the network, you could pass and receive messages. There was no checker balances. If you were a malicious actor and had access to the network, then I am sorry, I am having a utility work done in the background, in the backyard. I'm gonna put you on hold for 2 minutes. Jim, you wanna take over for a second?
Oh, sure. Yeah, we can't hear anything, but all right. Yeah, so speaking of ROS, I had a very little experience with ROS2. ROS1, I went through the this nanodegree program from Udacity, the robotics engineer nanodegree, and I got to use ROS1 for quite a bit, and ROS2 actually at Samsung, where I work at Samsung Research America in Irvine here, and we had to deal with ROS2 for just very specific improvements that they've made. I think it was might have been with a cartographer or something related to that, but the basic, I mean, in general, yeah, ROS has been very interesting to learn from scratch, taking that course, and it really there's an introduction book that's free that is very good. We can post that for people who don't know about it. But the ROS doesn't, especially for anyone who's got some background in software engineering, but even if you don't, the concepts are fairly straightforward. Message passing is the main concept. So you can have a device, you can have a core robot, and then you can have different sensors, and the sensors, and that you could have this core running on, say, a Raspberry Pi 3 or better, or it does it, and or other devices as well, Windows. Mostly Linux is the platform, but then your sensors can be, you can run multiple processes, multiple ROS publishers, essentially, that or client. There's clients and servers, and clients subscribe to the servers, and what you can do is you can have each sensor on your robot publishing the information, like I am here, or the distance to the distance that the sonar is getting back. It's sending a pulse out. It gets back this distance. That's mounted on the front, and then that keeps publishing. And then your main code can subscribe, and it will get updates. For those who don't know about ROS, so it's really cool. And then you can the main routine can also publish information back or send it, so that there can be a two-way communication as well when you need to handshake. But it's what I think of it is, as a new ROS person, really, it's this concept of publishing and publishing information like a sensor would do, and you can have several sensors, including a camera. So the camera can publish its frame, and then your main code can get that frame and do something with that video data, run it through some sort of algorithm that will detect objects, sending it to more advanced software, and then and then all the other sensors come in, and you can get all that information. But on top of that, ROS really has these tools that are really great. There's something called the RViz, and then which can visualize all this data coming in a graphical form. So it can visualize the say LiDAR data coming in and show you it in this application, in a Windows, or it's on in a windowed application. It's usually under Linux. There is a Windows port, but that's it's kind of new. And then there's the other tool. Yeah, I forget the name of it. The other tool you can model. You can see the whole world of your robot and its environment, and you can build. You can bring in objects into there, and it has a full physics simulator. So things will fall down, and you can, to the ground, and you can build up a robot, and a gazebo. It's called gazebo, and the gazebo is a full 3D environment, and that is, and it even has a little building editor. You can make very quick, cut and dry buildings made of just walls and windows, and with no roof, but and then so this is an area indoors, and so your robot then can drive around there. So this is a full simulator with physics, and you can just construct your robot in a file with all the different parts of it, and it usually, first just physical parts like a cube, and then wheels, like cylinders for wheels, for instance, and then but then you can add a camera on it, and you can specify, and they have examples do all this, but you can specify a particular camera or a LiDAR unit, and then there's support for that in a ROS library. So that physical model, and it could be a what do you call it, a mesh graphical mesh that will draw, and so that it's more complex than obviously a cube or sphere or whatever. And so then that camera will actually be able to function once it's hooked up, and you see the little representation of that camera or a LiDAR on your physical model, this 3D graphics model. Anyway, so that's just a little
Sorry
bit.
about that. I should have announced it before we started. I'm having some utility work done in the backyard. So we pulled away for a few minutes here and there. We're almost finished. I labeled sharing for everyone. Jim, did you want to get a couple of show and tells out of the way before I come back?
Oh, okay. Let's see. Were there anybody? Let's see. I haven't seen anybody on the list here who's asking for one. Oh,
no worries. I'll be back in just a minute. Thanks for your
yeah,
patience.
it wasn't just the noise. You had to go talk to them, right? Yeah, I think he had to go talk to them. It wasn't the noise. I mean, I tried to say that from the beginning. Yeah, so for show and tell, is anybody? I didn't see anybody listed. Who's anybody have anything to show today? We can start. If not, I have. Well, I can show. I haven't really prepared anything, but I can show my.
Jim, I don't have anything for show and tell, but I might next time. What is the procedure now to sign up for show and tell? How does that work with these virtual?
Yeah, well, we're gonna. We want people to go to the chat. If you can get the Zoom chat at the beginning of the meeting. I should have announced this, but we kind of we sort of decided that we would like everyone to list their name and the time they need, kind of like the old whiteboard technique we used to use, but just type it into the chat at the beginning when we, like in the first 15 minutes, or if you arrive late, then just type it and send it to, you can send it to everyone, it doesn't matter, or Ben or me, you know, whoever's here. Ben will, it's fine to send it to Ben when he's here. So, and then what we'll do is we'll, towards the end of the meeting, after the talk, then we'll go from the list of people that are signed up. But it's gonna be at the beginning, basically, sign up. And then we'll have to limit based on the time. We would like to wrap up, by 7:30 or 7:15, something, not too late. So we'll, I see that R2, Robert. That was another R2. Dennis is R2. Yeah.
Oh, we're gonna have a competition who has the biggest R2?
Oh, I think Thomas might win that one. No.
No, I think I'll win it.
Who's, oh.
I don't know about that.
Well, maybe Walter.
Yeah.
Well, that's true. Walter, how's your R2 going? Didn't you were building a few of them, or more than one, weren't you?
Yeah, I stopped a couple of months ago. I've been doing other things, but yeah, no, I haven't progressed on anything.
Right, but that thing.
I hope we have a build day soon.
Yeah, I was actually working with Rob on building one. So
yeah, I'm hoping we're gonna have a build day soon. I talked to some friends, and
good.
Maybe within the next month we'll have something going on.
Sounds good to me.
That's
yeah,
cool.
It's been sitting there.
Yeah, mine too. And unfortunately, because of what's going on with me, I can't do much.
Yeah.
So I don't have the physical ability yet.
Oh yeah.
Right.
You told us before, right?
So, yeah.
Well, I can show. So I can't see what. Let me show my self view so I see what I'm seeing here. So This is, you've probably seen this before. This is the my big orange robot, and with the Slam Tech on the top here. This used to be a robot, and I took the wheels off and the motor and mounted it on this big thing, which was a platform you can buy. And this here is a Windows machine, the Latte Panda. And so now I'm moving the whole thing over to Python, which Dr. Bruce did this 1.5 years ago. So I'm a little later, but of course I started a lot later. And with the Python, currently the code is it's running just on Windows Win32 code that Alex and Gary helped build. And with the interface to the SlamTech core, Slamware core is all on Windows Win32. So there's a whole API, which is kind of cool, that you can give it commands to go go somewhere on the map. The thing maps for you. You drive it around and it will map. And there's a full API in Windows. And so what we did is create a DLL that exposes all those Windows APIs, or the SlamTech API to Python. So now you do everything in Python, and what's important about that is a lot of the Google cloud services are in Python, like the text-to-speech and the speech recognition. So it's nice to have everything in Python, including the SlamTech. So that's a whole benefit of if you have something in one language, you may want to expose it to another language. In this case, C++ code is exposed, API is exposed to Python. And Python can be a lot easier to use. No compiling necessary. I see Alan's back.
Hey, thanks, Jim. If I could jump in here. Sorry about that. It's no drama or anything. In addition to everything else that's going on, and right now, I'm having some sewer line work done in the backyard, and I'm not sure if I'll have to take that tree down that's bending it down or not. So I've got some people coming in for some quotes, because, you know, as if 2020 couldn't get any more exciting. Let's take out trees and stuff. All right, so let me go ahead and share my screen again. And let's go ahead and get to the meat of it. These are all the things that ROS2 is promising, and for more or less it delivers. It's a more modern framework. It uses modern C, C++, and Python 3. It solves for some use cases they didn't even take into account before. You can control multiple independent robots simultaneously. It has baked-in support for real-time OS. So for soft and hard real-time requirements, if you have dabbled in those, it is now officially supported without having to have a secondary subsystem that runs in RTOS that communicates using messaging. It's supported as a first tier, main citizen, however you want to call it. For communication, ROS is a communication framework. So that's one of the things it brings to the table. And just like with Arduino, when you play by the ROS rules, you get to use all the toys in the ROS toolbox, including everyone's abandonware and currently supported projects that they've done as part of their college theses, etc. You can make use of that code, and more often than not, you can just download it and compile it, and it just works. More often than not. Whereas there's only one communication layer available in ROS2, now there's at least 2 or 3, plus you can bake your own. So you have complete control over how your different nodes and programs communicate, that from the network layer on down, quality of service, security, just super awesome, super awesome. And to briefly talk about some of the benefits of ROS1 for those of you that want to get into it, there is a lot of information out there. I always nudge people towards the free online book, A Gentle Introduction to ROS, something that you can want to read cover to cover a couple of times. The information is presented just so well that it lends itself to a cover to cover read. There are dozens and dozens of robots that have ROS frameworks already built out for them. So you can download their framework, you can pick it apart to see how they solve the problems that are each of that robot and leverage that knowledge to on your own bots. There are dozens and dozens and dozens of books. We've recommended a few of them here. I think that list stops at Sense and Sensibility. That's an odd inclusion. And of course, there's a very richly, in addition to all that, set of ROS tutorials. It'll take you step by step on how to create a basic framework and understand basic ROS concepts. And so this is all the stuff that's going for ROS 1, and that's out there right now. So when I moved the Todd framework from the previous version of ROS to ROS Noetic, it was basically a matter of installing the updated version of ROS and then hitting run. All my stuff still worked. It's a stable API. There are cases where you do have to dig into forum posts, and once or twice, I have had to read through the sources, the old use the force, read the source mentality. But for the most part, the information's out there. The answer's out there. It's just up to you to write the right Google search term to pick it up. And that's one of the major strengths of ROS. Again, getting back to solving more problems than it causes. If you know, you're writing a solution that involves a computer or a Raspberry Pi where you want to write multiple programs that communicate with each other and have some control over that communication as well as an ability to log it, or you want to use someone else's tool or module if they've already written for ROS, then ROS is, you know, where you want to go. And there's lots of stuff out there that doesn't require it. I tend to favor it, not only because for me, when all you have is a hammer, everything is a nail, but it allows a unique and I think approach that resonates with me, and an approach for solving some of the more complicated programs and problems in robotics that that resonates with me. So I'm at a crossroads right now. We'll switch over to Todd. So what you're looking at right now is Linux. I know that they do say that ROS and ROS 2 are now supported in Linux natively, of course, but also Windows and also Mac. At the end of the day, the old adage, does it solve more problems than it causes? If your framework's written in Windows and that is where you need to stay, then you'll deal with the rest of it. But my experience so far is that you can download and install the basic framework in Mac or even in Windows. And you can do the hello world examples, but the moment you try to pull in code from other people, everyone else who assumed that you're doing your stuff in Linux, it doesn't work out so great. So I've been using Linux for about 20 years now, so it's second nature to me. But for me, at least, again, solving more problems than it causes, it makes more sense for me to stick around in Linux than to try to work in the adapted framework in Windows. And one more thing I wanted to show you is that when they say that it is supported in Windows, let me show you what the installation steps look like to get the newest version of ROS 2 installed in Windows. So Foxy, oh, sorry, I had some feedback there. So Foxy Fitzroy is the latest, I believe it's the LTS release, the long-term support release for ROS 2. They've had a previous long-term support release in the D-dashing something or other. And what that means is that the platform and the API is stable enough to start using it without fear of them totally refactoring something. So they're relatively confident that the things you're looking at now, that their approach to ROS 2 won't change significantly as they move forward with future versions. So let's look at, and I'm not trying to scare you away. If you're solving a problem where it makes more sense to run this in Windows than in Linux, this is definitely the direction you want to go. But there are a bunch of things, a bunch of steps that you have to install other stuff outside of the ROS framework to get it to work. So They use a tool called Choco. Pip, for those of us who use Python, is an install tool that they leverage. There's a bunch of extra stuff that you need to install outside of the framework. They want you to install Qt5 separately. And then once you do all that, you can get the ROS code and then build it and the environment set up. So again, the instructions for this are a lot more complicated than just running it on Linux. So what I'm showing you right now is I'm actually, for the sake of this demo, I'm going to be running actually both versions of ROS 1 and ROS 2, in VMware Player. So it's a virtualization layer where I can run Linux as a program, which is what I'm showing you right now. I'm using Pop! OS because I think it looks prettier than Ubuntu. It's based on the same Ubuntu and Linux code base, but the design language is more Mac-like. So it looks pretty familiar. It's a joy to use. It's a lot of fun. So what I want to show is show you what our goal is. So my goal was, okay, Alan, you want to evaluate ROS 2. Let's recreate something in ROS 2 that you did in ROS 1. So just give me a second to set up the environment for ROS 1 right now. So there's a configuration file where I say, hey, pretend you are doing ROS 1. And it's already set up for that. So in typical ROS 1 fashion, ROS launch, Todd the quad type 2, description, gazebo launch. And after a couple of seconds, we'll get my basic framework. So it's going to bring up the robot visualizer, RViz. It's going to bring up the physics accurate, well, the physics approximate simulator for the robot. So we've got this guy brought up on this side. We've got this guy brought up on that side. We're not getting any position data because the simulation hasn't started yet. But once we start the simulation, it'll do something that's very robot-like, and it'll collapse, right? Yay, I made a robot that fell down. But it's a physics-accurate simulation of frictionless servos and what would happen if you started reality standing up. You would just fall down. And so this is my ROS 1 framework. And my whole goal was to move this over to ROS 2. I am so sorry. Jim, take over for a second.
All right, I'm back. Got call. Yeah, so this is exactly what I was talking. It's kind of, I guess it worked that I was mentioning gazebo and RViz, because then you really don't have a ROS session without gazebo and RViz coming up. And gazebo is really quite amazing. It takes some effort to build your robot up. Like I built that, when I showed you, I kind of built a really rough version of that inside that gazebo, and just using a cylinder, three like pancakes, and then cylinders for the wheels. But it was all in this written language. You had to, or written specification. You had to specify each part, or each like a primitive, primitive being a sphere or a cylinder, and then exactly position them with the numbers. So it's a little bit of a hassle to do that. There's not a GUI editor. You back, Alan?
Yeah, sorry about that. I really apologize. There's just,
those guys are kind of late here. Usually people don't work this.
Yeah, it's a full day job. They thought the pipe went one direction, and it actually went another one. So yeah,
oh, they started early. I see.
Yeah, so they're doing well, but again, I apologize for the interruption. So to get back to ROS 2, I said, okay, well, I've got this recreated in ROS 1. It's a super impressive demo of a physics-accurate simulation of a robot with frictionless joints. When you start the simulation, it falls down. And when you go through the steps in the hello world for ROS 2, it gives you some instructions on exactly how to install the ROS 2 framework. some general tips on some of the differences in launch files for launching combinations of programs, and you know, a new semantic for writing Python nodes and stuff. And that's all boilerplate. Like once you learn how to do it, it's relatively straightforward. But that's where things become a little more complicated. And the overriding theme for this talk today is, does it solve more problems than it causes? So here's where we're at. We have a new framework that does all this awesome stuff. Sounds like fun. ROS 1, noetic. That's the last version of ROS 1 that they're supposed to publish. So there won't be any new versions. That is a finished platform. All new work's going into ROS 2. Is it time for me to move my little Todd guy over? Now on the ROS 1 side, we have a lot of examples and tutorials and forum posts and books and all kinds of information that we can leverage to figure out how to get from point A to point B. And the Todd fits well into that, because the only thing really unique about Todd is the 3D design, controlling servos, ROS on Arduino, the IMU, the camera. This is all stuff that people have been using on the Raspberry Pi and ROS for a very long time. It's just, it's coming in a little bit of a different shape, right? So we've got this little guy right here, lording over a pack of cards and a voltage regulator. So what happened as I tried to migrate this framework over to ROS 2? Well, and Sergey sent me a great article on this, and there's a couple articles that touch on it. And again, it depends on what problem you're trying to solve. Like someone like me who's a dabbler, I'm not a ROS doctorate level researcher who's building robots for fame, fortune, glory, or profit. I'm tinkering, like, you know, most of us. I've got a cool idea for a robot. I want to leverage these types of toys to do something interesting with it. And I'll dig as deep down as I have to, but usually no further. And this is one of the main challenges between ROS and ROS 2 right now, is that when you start getting your feet wet in ROS 2, you don't have that back library of examples of forum posts, of books to lean on. And let me give you one small example of that for this framework. So right now we are in the my ROS 1 example of it. I have a whole other copy of this when I was porting it to ROS 2. Let me go ahead and open that up. The affectionately called ROS 2 Todd workstation. Now, and this is just one of the things I ran into, is to port this over. I've got a bunch of things that already work. I have this RDIF XML-like description of the robot. That's what's used to generate the visuals in RViz, and is the basis of generating the visuals and the physics in the Gazebo simulator. And I've written this XML, this description of the robot, using a macro language called Zacro. You don't have to do it. You can write like raw HTML. You can write raw RDIF to generate the robot. But what's nice about using a macro language is for things that repeat or things that you see a pattern to, I only have to write the Zacro code for one leg. And then with a couple of tweaks, I can tell it how to behave for the other three. So it's a time saver. So you've got this macro language that describes how this robot works. And the tutorials in ROS, there's actually top-level tutorials at ros.org that explain how to write a Zacro file, and then once you've written it, how to pull that Zacro file into your project and make it live. Now, when I moved to ROS 2, I kept getting errors. And I couldn't figure out why. Now, in the olden days, in ROS 1, you write these XML type files that describe how you want these things to launch. You don't have any control over what order they launch in, or if one finishes before the next starts. And truth be told, these launch files were being interpreted by Python applications and modules in the background. So one of the other main benefits of ROS 2 is they're like, well, let's just get rid of the middleman. Why would you write something in XML if you're going to process it in Python anyways? So the launch files are now just written in Python natively, and you import the modules that were being imported by the interpreter, and you're more or less doing the exact same thing that the interpreter does as it reads through that XML file. And
That's
here's
good to hear. That's
yeah,
something
yeah.
I had to deal with all those XML files and didn't like them that much, really. This was through with that course I took, but it's just like, yeah, it's weird to have that mix.
Yep, for sure. And so, and it's one of those things where, like, if you do a lot of this, you can kind of memorize the pattern. But if you're anything like me, you find an example of the internet, you adapt it to what you're trying to work on, and then click cat can make or Cole can build, and you're good to go. The first thing I ran into was there were no examples of how to pull in the Zacro file, the macro representation of my robot. And it reads like XML, and that part hasn't changed. But there were no examples on how to pull a Zacro file instead of the macroed ERTA file into it. And it took me a minute. Let me show you the steps I had to go through to get there. Is first off, after a couple hours of reading, I had noticed that someone said that these Python launch files were using the same Python modules that were being used in the ROS1 system. So I did a quick search for, not Guitar Center, GitHub, Zacro, and poking through the GitHub and the source file for this, I figured out that there was a function in here that will read in a Zacro file and output a mini DOM XML document with the unzacrofied information. Okay, well that's great. Let me try feeding that over to the script. You can tell by the tone in my voice how well that worked out. It didn't, because it turns out the script still wants a textual string that represents the XML, the ERTA of the entire robot. So you get an error. Like, I don't know how to do DOM. I just know how to do text. So after a couple more hours of searching, and there really aren't even any examples of this. There's no forum post. You just have to figure it out. Here's the line where I process my Zacro file and I process it into a DOM, a document object model, or a mini XML DOM. And after a little bit of poking, I figured out a couple of hours, because I'm not that sharp, that there was another function to convert that into a text string representing the ERTA raw string ASCII ERTA file. And from there, I figured out how to hack one of the examples to push that in. So that was about 8 hours of work, because I'm not that sharp and there were no examples. And this was just to get the visuals of the robot to show up under RViz. And that's actually the state of ROS2 right now. Is you have a solid framework, a stable API. If you download the standard ROS framework and install it, it'll behave just like the tutorials say. You can run your hello world subscriber and publisher node to get a feel of how the Python or C++ files change to build the most basic communication type nodes. But the moment you step out of the simplest example, it's still a no man's land. It's too new. There's not enough people out there smarter than me who have already paved the way and posted their experience that I can leverage. You'll be doing a lot of original work as you go through. And when I was trying to research this was solving for the first half of it, just to get my Zacro file into RViz to display it. The second half of this was how to get that same file into Gazebo, the physics-based simulator. And there are a similar number of challenges over there, just completely undocumented gotchas. Hopefully you are competent enough to read through the source codes or know your Google Foo enough to be able to word a search query that you might get a forum post from one of the main authors of the Gazebo ROS2 integration, for example, who may have mentioned something in passing that may relate to the problem you're saying. From that sense, the whole ROS2 ecosystem isn't mature yet. You're going to be doing a lot of original work to be one of those trailblazers. It's not to say that it's not fun and that's not if that's your passion, and that's cool that you shouldn't. But where I am with Todd right now, this is my crossroads, and this is why I don't have an answer even for the Todd project yet, is that the purpose of the Todd project was to look cool and to provide an example of multi-machine operation with the brains in a laptop and enough brains on the robot to get vision and tell it to move and get IMU and to do some fun stuff, right? So there's no practical application to it. But because it's built on the ROS1 framework today, you get to play with the rest of the tools in the ROS1 frame toolbox. So if someone way smarter than me has adapted the you only look once, the YOLO single frame image classifier, and has put a ROS wrapper around it, so all you have to do is download their code from GitHub and hit cat can make, and you communicate with those packages. That's fun, right? So that's what I like to do. You don't have any of that on ROS2. Let me show you really quickly what it looks like. This is just one of the migration guides for.
How come aren't they usually? I mean, the little I've seen in ROS, that the authors generally write a little how-to. I guess that hasn't happened yet, and for even some critical things even.
Yeah, it's right now they haven't even really separated out the wiki. Like, it's not, everything's built around ROS1, and if you poke around or Google search, you can find some of the ROS2 entries, but they only cover the highest level concepts right now. And that's not to say that they're obligated to, or that, hey, you guys who are coding for free, you need to do better documentation. It's just to say that even though the framework is mature and it says what it does and it does what it says, for someone like me who prefers to leverage the rest of the ROS ecosystem to stand on the shoulders of giants, there's just nothing else out there yet. So to get back to Todd, let's say, for example, I say, you know what? It is time to move Todd to ROS2 because reasons. On the Todd robot, there are 5 nodes that have to run. Each node communicates with a different piece of the hardware. There's a node that communicates with the I2C servo driver. There's, of course, a camera node, an ultrasonic node, an IMU node. I think there's another one in there, but I can't remember. All of those have to be ported to ROS2, and the original authors, I don't know if they're still active or not, but they haven't done it yet. So when you're looking at converting someone else's package to ROS2, there are a couple of steps. It expects that not only that you're fairly well versed in the ROS1 build system, but also the ROS2 build system and C++, which I am a master of none of those. Now, even if I move the Todd framework over to ROS2, and there are some other benefits, it's using a newer version of Python. I expect some things to be faster. I hope some things are faster. There's something called masterless operation, where you don't have to set up one system to be the master and then everyone communicates with it. You don't have to plan ahead. It uses a masterless discovery mechanism, where as long as you guys are on the same network, any nodes can self-discover and communicate with each other, which is super cool. And there's even a ROS1 to ROS2 bridge. So let's say we move Todd over to ROS2 for whatever reason, and it sticks because it solves more problems than it causes. There's a ROS2 to ROS1 interface, or pardon me, middle layer, that you could use to run ROS1 code to communicate with nodes in a ROS2 environment. But for me, I kind of feel like that's one step too far. So now, you have to learn ROS1, you have to learn ROS2, you have to learn the ROS2 to ROS1 bridge. That's 3 whole frameworks where only one would do. And this isn't the crossroads I'm at right now. Maybe I continue to develop the framework under ROS1, and then I set up a dev branch for ROS2 for those that want to get their feet wet. But I'm having a hard time committing to ROS2 for Todd because there's no ecosystem of shoulders that I can stand on to do fun stuff. I'm having to do a lot of original work to figure out, even going so far as reading through the source code to understand in Python how to get from point A to point B, because there's just nothing out there yet.
Yeah, that seems like a lot of Herculean effort. It's maybe too much for you may not. It's just you can wait, I guess. if unless those features really are important to you that it adds.
Right, and that's what it comes down to is for any framework you're looking at, whether it's ROS or ROS2 or making your own or Arduino, does it solve more problems than it causes? And that's not a question I'm sure I know how to answer for something even as specific as Todd, because even if I poured over those 4 or 5 nodes and take advantage of Python 3 and the newer C++ and masterless operation and make it even easier to use Todd as an appliance that you can just connect to, after I do all that, you're still stuck either porting every single third-party module over to ROS2, which most of us don't, myself included, don't have the skills to do, or to learn an additional ROS to ROS2 interface layer kludge to allow you to communicate with that. So I'm kind of leaning towards keeping him on ROS1 noetic for a while, but toying with ROS2 as it matures. For those of us that, and I'm not in this case, but if you're an equipment manufacturer or a major OEM or a company, you'll definitely want to start involving yourself because that is the future. But for someone, for me, who just likes to dink and toy around and wants to do something cool and fun that other people can do too, I'm thinking I should probably keep Todd and ROS1 for now. What do you guys think?
Oh, I was going to say, Alan, the Samsung project I worked on, it was a robot contest, and it was all in ROS, and they had a Unreal Engine that was hooked. Obviously, that was the renderer, but it connected to it obviously subscribed to the ROS topics and everything. But I was going to say what was I just going to say? They did use the bridge, ROS1 to ROS2 bridge that I think you mentioned, and it basically worked, but things would, and this was a year ago, about a year ago. I don't know where they're at this time, but well, they didn't have another contest this year so far that I've noticed. But that bridge, yeah, seemed to do okay, and it was, so if you really need something, you could get that bridge working. Although it might have, I'm not sure there was, if it crashed, there was definitely some hiccups, but that was my first ROS experience with a ROS2 piece and a bridge to ROS1 and ROS2. So it was doable anyway.
If I may, I have a question about this topic. When you were learning ROS, as you're learning ROS2, how much did your previous understanding of ROS help you?
It actually made things more difficult because every time I approached a ROS2 concept, and I understood the bylines and the benefits, and I was fully invested in learning it, but I kept bringing all of my ROS1 baggage over with me, and it kept getting in the way more than helping me. I honestly think that if someone is approaching ROS2 with no ROS background and someone is approaching ROS2 with a ROS1 background, as long as you've got some Python experience, I think your ROS noob is going to progress faster because they're not relying on things being there and working the way they used to. And I lost a couple of hours, not to complain, but I spun my wheels and lost a lot of time trying to force my understanding of ROS1 concepts into ROS2 paradigms and failing. It didn't fit. It's doing things differently. And the moment I kind of took a step back and said, okay, let's not treat this as a new version of ROS. Let's treat this as an entirely new framework in the spirit of ROS. And then I was able to, approach things in a way to get questions answered and be less frustrated. So that when I took that step back, that's when I said, okay, this is Python. How do Pythonesis handle it? Okay, let's look at the source code. Then we found the function, and okay, well, this gets us to the DOM. Is there anything that gets us from mini DOM to XML? And gosh, I hope that XML object is a string value. So once I detached myself from there, the principles of ROS still apply with messages and stuff, but I kept getting held back by expecting ROS2 to behave the exact same way as ROS1.
I see.
If that makes any sense.
So it's that radically different. Well, that's the extent of their difference, where a lot of the things you understood from ROS, where a lot of the concepts you understood from ROS don't necessarily carry over just because it has a 2 at the end of it.
Yeah, that's been my experience so far.
Okay, and then the second question I have real quickly, I'm sorry, but how long do you expect, now that ROS 2 is around, how long do you expect the original ROS to be in use in the future?
Well, the official party line is that ROS 1 Noetic is the last long-term and the last release of ROS 1. Whether or not they stick to it or not, or with enough funding and interest, if someone tries to go further than that, I think you're going to see ROS 1 and ROS 1 Industrial and ROS Solutions out there for at least the next decade as people move over. Because everyone's more or less like me right now. It's like, okay, well, you're saying
Right.
ROS 2 is out there and it's stable. Here I'm dipping my toes into it and oh my gosh, so I have to do everything from scratch. Why isn't there anyone to help me? So whether that takes a couple of years or 5 years or 10 years, or maybe they maintain parallel frameworks for the next 10. I think it's too early to tell. I know that we're starting to see more articles that are nudging people to adopt ROS 2, but and this is one of the things that fooled me. I said, is ROS 2 ready for prime time? Like, yes, it is. Let's devote endless hours to figuring it out. And then I actually read through the article. And its point was, if you are an integrator or a manufacturer or a peripheral person, or you're a professor who wants to get a leg up on the coming ROS 2 revolution, absolutely jump in. Otherwise, if you're a beginner, stick with ROS 1.
I see. Right.
Yeah, I would add that that full nanodegree program I took, from Udacity did not mention ROS 2, and not even once. So, and that's a full degree, nanodegree program, and there was no education about it. So that's supposed to prepare you for industry, for current needs.
Yeah, if you're looking for like a job right now, I would be surprised if there was anyone requiring ROS 2 experience. But any job listings out there that require ROS experience, I would expect that would be in ROS 1, and that should be the same for the foreseeable future.
I see. I'm just wondering, because since there's now 2 versions that are considerably different, as new people are getting into ROS, they're going to have to, I feel like there's going to be some selection of one or the other.
Yeah, and it gets back to one of my mantras and main themes. Yes. Is, does it solve more problems than it causes? And at some point there will be a tipping point where it makes sense to live through the warts to get the benefits of that. It's just where I'm at now with a specific project and a specific need. It feels like it's a little bit early for me.
Okay. Yeah. But it's still worth learning the original ROS.
I would definitely say so.
I think so.
Yeah, it's an open-ended framework with lots of toys contributed by other people that elegantly solves a bunch of problems that people run in with robots today. And there's some things that it doesn't solve that well. That's why, like, Boston Dynamics doesn't use ROS, because it didn't have a bunch of reasons. Some of the ones that I've heard are that it didn't support any real-time kernels. You had to run a whole separate computer and subsystem with any real-time requirements. Quality of service, security, things that seem pretty obvious to solve for now weren't obvious when ROS was first created for the PR2. So if you're developing a commercial product, those are things that might weigh heavily on your decision to use one framework or another, because ROS 1, in many cases, it's just not ready for prime time like that. Where ROS 2, they're solving problems that people are doing with robots today. And it may make sense, like right now, for someone to bite the bullet, take advantage of the ROS 2 benefits, and then just wade your way through migrating code over.
I see. Okay. Thank you so much.
Yep.
Right, but for hobbyists, we hardly ever make it that far as a commercial product. So if you're fortunate enough to build a robot that needs more advanced features than ROS 1 can do, then congratulations. You'll take on ROS 2 without any problem, and by then maybe those drivers will be written, so you don't have to. No one wants to write all the libraries, to support hardware, and that's not fair. That's not. Hobbyists don't have that kind of time. At least I don't.
Yes.
I have a question actually. You took a difficult path here. You took a robot that you already had kind of operational with a lot of modules, a lot of investment in the current building structure and everything else. And then you started porting it in a way. So that complicated things more than it solved things. When you start from scratch, the process is very different actually. The process is that you take a very basic sample and you build it reliably and you start from that little, you know, kind of egg and develop it into something realistic, you know, realistically behaving by adding modules and stuff like that. So that might be a very different experience in terms of complexity, in terms of finding unknown, you know, kind of islands of difficulty and stuff like that. And in this case, as you both mentioned, Jim and you, Alan, bridge is a big help. Because if you build from scratch on the ROS 2 side, and you reliably can kind of build little things from examples. And then whatever is not easy to build, you build on the ROS 1 side of the bridge. So my question is, how much did you learn about the bridge and how much we know about the bridge, what it does? I mean, does it become a transparent kind of wall between the two environments? Do you have to run it on different machines, the two environments? How does it work with the bridge?
Well, I'll be honest, I haven't gotten that far with the ROS bridge yet. Jim, did you mention that you had some experience with it?
Yeah, I can't, I mean, this was over a year ago and I can't speak to the specifics, but it did function, it allowed the cross-pollination without too much. I mean, I was a user of something that was set up for me, so I didn't get into the nitty-gritty detail, but you just launch the bridge and you'd have this heterogeneous processes of ROS 1 and ROS 2 going, and it seemed to be functional. But I'll leave the more details up to you to look into. I think it's definitely usable as a transitional period, or for a transitional period, but only if you really need ROS 2 feature. Otherwise, do the whole thing in ROS 1, unless you're a company or, you know, or really need the feature, right? I mean, that's my opinion.
Also, there is a consideration that now a lot of book authors, they race to get the books out first, you know, for ROS 2. Because those guys who were writing ROS 1 books and had all the connections to the original, you know, kind of authors of the code, they have to earn their living again in the new infrastructure.
Yeah, and I'm really hoping, I'm plugging someone else's book, but at some point, even if I have to pay for it, someone comes up with a ROS 2 equivalent of this free online book, A Gentle Introduction to ROS. The concepts are the same. Of course, the devil's in the details. Sergey, where I think my stumbling block is it is definitely challenging to move a framework from one to the other. But what I was finding was, as I wanted to solve those same sets of problems in ROS 2, there just wasn't any information available on how to do it. There wasn't any online examples or other people smarter than me that have published robots with similar features on it. I found that I had to be a lot more creative than I normally have to do in applying the ROS framework. And I think that's where some of my frustration was. There just isn't a lot of information out there yet that you can leverage, except maybe a forum post or reaching out to the person who actually wrote the module in ROS 2 and finding them on Discord or Discourse and asking them directly. It's so that's the part that I don't feel it's mature yet. The framework itself is fine. But once you start wandering out of these highly simplified examples from the ROS2 wiki, there just isn't any information on how to do equivalent things in both platforms yet.
So my assumption that the sample code is there and you can build simple things easily, that assumption is too early yet.
Well, yeah,
it will take time to create those.
Yeah, no, and let me go ahead and bring up another tab here. You are right in that there are simple examples there. Let's do a quick the equivalent of hello world, and looking at the page, oh look, there's a bunch of stuff. If you're anything like me, after you install and read through the introduction to the ROS concepts, and a lot of these concepts are the same as in ROS 1, you write a simple one program that talks and one program that listens. This publish and subscriber example in Python. And depending on if you're OCD like me, you'll either type out the code by hand or copy and paste it in, and you can launch them, and it is what is on the it says on the tin. It does what it says, and it says what it does, and that's great. And it gives you a basic grounding in internode communication using simple message topics in Python. And in my case, where I needed to port over the existing framework, so I have the robot in XML code and RDIF. I have setup files to get the RViz robot visualizer set up so you can see what the robot thinks of the world around it, and to set up the gazebo environment, the physical space simulator. As soon as you wander from the simplest hello world example, you're kind of left holding the bag. There's just no information on how to do anything beyond the simplest example. And for that Zacro cloud, we're like, oh, Alan, you're your own worst enemy. You shouldn't use Zacro to begin with. Something that is like in step 3 of the introduction to RDIF and gazebo tutorials in ROS 1 or step 4 doesn't even exist in the ROS 2 tutorials yet. So then it's up to you to figure that out. And it turns out there is a solution. You just got to get your hands dirty. That's probably the most frustrating thing right now.
Well, Alan,
is there a Turtlebot or something of that kind? Turtlebot, functional robot there?
Yeah, Turtlebot's written in RDIF, and so there's some simple examples of the Turtlebot 3, I think, the launch file, and the Turtlebot 3 launch file launches an RDIF file, not a Zacro file. So it was up to me to figure out, hey, how do I call in the Zacro module to read in all of the Zacro macros and convert it into a DOM in there. I'm caterwauling like it was the end of the world. It took me a couple of hours because I'm not that smart, but there's no other examples out there. So if I were to write a forum post on how to launch RViz with a Zacro model file, that would represent the first forum post on the internet about how to do it.
Oh, it's because RDIF is, I'm forgetting, RDIF is for one and Zacro is for the other. Is that the?
Yeah, and this is just one example of like a dozen that I ran into. I just wanted to focus on this one because it was the first thing that irked me. There's just not a lot of example code out there outside of the simplest examples of how ROS 2 works. And that's going to be the case for a couple of years, I think.
Yeah, that's a problem. I mean, it's just obviously we rely so much, at least I do rely so much on example code to get going, and tutorials and how-tos and things like that, because unless you really want to read source code, and I mean, sometimes you have no choice, but you want to limit that to choose your battles.
Yep, everyone has their limit, and I'm not averse to reading in C++. I'm not an expert in it, but I can follow patterns pretty well. But yeah, it's I think what I'm going to do is I'm going to continue developing the ROS 1 framework primarily, and then I'll set up a branch for ROS 2 and start dabbling with it, because at some point I'll have to switch it over. And heck, this isn't a product, I'm not selling it, we're all doing this for fun. But if I'm going through the effort of publishing this for other people to use, I might as well do it in a way that's accessible and makes sense. So I think Todd's going to be ROS 1 for a little while, and while I continue to dabble with the ROS 2 stuff.
Well, you should definitely contribute the things, the examples that you've kind of created. for ROS 2 into the like you said, post it. So
yeah, they definitely need the help.
yeah.
Have you gotten ROS 2 to work on Pi 0?
Yeah, I have successfully compiled it's not really cross-compiling. The Pi 0 is an anemic first-generation Raspberry Pi. So all Raspberry Pis use the same 32-bit Raspbian OS. So I cheat. I've got a Raspberry Pi 4 off to one side. So I'll load in Raspbian, and I'll go through the compile from source steps to compile and install both of them, ROS 1 and ROS 2. On the Raspberry Pi 4, and then I'll move the card over to the Raspberry Pi 0 and boot it up. It's 20, 40, 50 times faster than the Pi 0. So I'll do all the framework stuff on the 4, and then I'll pop it into the 0 in the robot when I want to use it.
Are you sure that'll work? The Pi 4 is 64-bit?
Well, the Pi 4 processor is 64-bit. However, Raspbian only recently released a 64-bit version of their OS. Up until May, I think, Raspbian was still 32-bit, and they were happy with that because their memory space topped out at 4 gigs, right? So they had a maximum 4 gig device. 4 gigs is the maximum memory you can address with a 32-bit address. And then they had to go and release an 8 gigabyte Raspberry Pi 4. When they released that, they released a new version or a variant of Raspbian that's actually 64-bit, and that won't run on the Raspberry Pi 0. So I'll have to continue my work on the Raspberry Pi 4 32-bit, and then kind of quote-unquote cross-compile to get that code onto the 0.
Alan, there is a middleware piece that comes from a different kind of company. So they allow you to compile it from sources, or it installs from deb files. How does it work, and what's your impression of that?
Oh, the install from source instructions?
My question is specifically about the middleware that passes messages and allows the discovery of nodes. That's a third-party tool, and there is kind of 3 competing middleware manufacturers for that, right?
Oh, I see what you mean. Yeah, there's the mechanism of inter-node communication. It was fixed. There was only one style in ROS 1. Now there's 2 or 3 versions. I actually have just been using the default, but even from my tinkering, the masterless operation, multi-machine communication, it all just works. You haven't even had a chance to evaluate alternative communication frameworks to see if one works better or worse across a single core Raspberry Pi 0 with 2.4G.
Well, definitely going with the default is the safe option. Even the article that I posted at some point, it mentions that they tried a different mechanism and they were not satisfied with its reliability. So it was buggy in some way, you know, and they just dropped it in favor of another.
Yeah. Interesting. If I ever get around to trying, if I even can understand what the differences are, I'll definitely try them out and share them with you. But yeah, so far I'm just using the default. I haven't measured it to see if it's any faster or more efficient than ROS 1 communication. I'm hoping it's a little bit more efficient because let's face it, there's not a lot of horsepower on the Raspberry Pi 0. There's just enough to get messages passed back and forth without any thinking on the robot. But one of the things I am excited about, right, getting back to solving more problems than it causes, is setting up ROS on the Raspberry Pi 0 as an appliance was pretty daunting. You have to set up ROS and you have to set it to start up automatically so it launches your launch file. You have to set up the network card to operate as an access point so you can log into it. You have to start the nodes necessary to communicate with the servos in the IMU, and your ROS master, your primary node, has to reside on the robot on a single core 1 gigahertz 512 megabyte processor, right? But I got it to work in ROS 1. It works. It takes about 3 minutes to boot, And once it's booted, you can connect to it with your laptop to the access point and get an address. And assuming you know the magic set of extra commands to stick into your bash RC file, you can communicate as a peer machine on the Todd network, and it pretty much works. And in ROS 2, they kind of did away with that for a couple of reasons. There's no master node. Nodes just communicate. So there are a couple of rules you can set up to kind of segment communication if you have multiple separate robots on the same network. But for the most part, the bring up for Todd would be simpler, because all you have to do is launch the 3 nodes or the 4 programs that you need to launch. And then when you log into the network, because it's still operating as an access point, you can just launch some more nodes. You don't have to know the magic sauce of setting some export definitions to tell your local ROS to communicate with a master on a remote machine. It all just works. So that part's pretty cool.
Oh, the remote stuff is a little hard. I haven't experienced that, but it's a little harder to deal. There's some setup for the ROS1 remote with the IP address of the remote device. That's not just simple. Like it's easy when it's all on one CPU, huh?
Yeah.
If it's across the internet, it's a little harder. It sounds like, but that's ROS2 fixes that.
Yeah, I'll bring that up real quick here. Let me see.
Yeah, we're about 7:20 now.
Yeah. So we're about ready to finish. And in ROS 1, when you have multiple machines, and this is baked into ROS, it just works if you know how to set it up. You just have to tell each of your computers where the master is and how to communicate. And it's only a couple of steps you have to do, every time. And then once you set it up, it just works. And in ROS 2, you don't have to use any of these glue statements, these exports, these things that point your ROS install at the thing. You just launch the node, and it makes some assumptions about any node that it talks to on the same network is part of the same family. You may or may not have implemented quality of service and security, and everything just works. Yeah, that part's pretty straightforward. And that's one of the reasons I might want to consider moving to ROS 2, because it makes interfacing to it simpler, but solving that problem then you have to deal with the ROS 1 bridge and 2 separate frameworks. So yeah, we're about ready to wrap up. Does anyone have any more questions? All right, thanks for letting me present. Let me go ahead and unshare. All right, Jim, you have anything else?
No, I'm good. I think I talked a lot more than I expected today.
Yeah, thanks for that. I'm really sorry about the interruptions. If I didn't have utility work going on in the background, that's just bad timing all around. But yeah, thank you guys all. We'll set up our follow-up meetup in 2 weeks.
Yeah.
That'll be a free-for-all open session.
Yep, free-for-all. That's our first time we're going to do that.
And I'm looking forward to it.
It'll be mostly show and tell. I mean, show and tells, but I think the way we'll structure it is what I said at to Jim earlier. We'll have people sign up. I think we still even though it's a free-for-all, it'd be nice to just have a little bit of structure so people could maybe write to the chat if they want to present and how much time they need, so we can roughly organize that. I think we should do. I mean, it doesn't, just like we used to do at the whiteboard.
Yeah, for sure. We'll have more time to get a little bit more in depth. Whereas at the end of these talks, it's like, oh, don't take up more than 5 minutes because it's going to be 8 o'clock. We'll have more time to chat and relax. I'm looking forward to it. Yeah,
I think it's a better format, and we don't have the pressure to get as many speakers per month or per year, I guess. And we get a good quality speakers and a good quality speeches, and then we have enough time for people to show off instead of rushing. So yeah, I agree. I totally think that's going to work.
Yeah.
Hopefully everybody agrees.
Yeah, stick it out for a spin.
Might have something to show next week. It'd be pretty cool. I'm not sure yet. I'm still trying to get it to work.
Yeah, 2 weeks. 2 weeks from today. Yeah, maybe I'll have something too. I don't know. If I get back, I think I'm coming back from a trip that day, but we'll see. All right, well, thanks for attending, everybody. And we had a few people, we had a person from Toronto and East Coast that I talked with briefly in the chat, and some, yeah, thanks to the people from the Homebrew Robotics Club, we have a few attendees tonight, and I'm glad we're seeing some, we're attending theirs and they're attending ours much more than before, so I think, so that's great. So thanks everybody.
Yep, thank you.
If there's anything
Jim,
else.
Jim, this is Bob. Can I ask one question?
Yeah.
I believe it was 2 meetings ago, someone presented a notebook, a special notebook where you could do some programming and keep your notes in the special notebook. Do you recall anything about that?
Oh, I'm not quite remembering, although it's not the new Raspberry Pi based notebook, is it?
That was probably Sergey. I think he's talking about your Jupyter notebook.
Yeah, Jupyter notebooks.
Oh,
Yeah.
Jupyter notebook.
Oh, that's it. That's what thank you very much. That's what I was trying to remember. Okay.
Yeah, Jupyter notebook is really great for the Python and deep learning as well, or any Python really, right? And it goes right on your web. You know, it's like a virtual machine in a web page, and you can type Python commands or go through tutorials, and you just hit enter on the little block of Python code, and then it produces the output right below it. So it's really, the courses on, I've taken 2 courses in deep learning from this guy Andrew Ning on Coursera.org, and those all use the Jupyter notebook as a lab for you, and it's all the most of the code is there, and you have to fill in a little bit of code where you're doing your homework, but there's plenty of tutorials with that. It's very good, Jupyter notebook.
It doesn't have to be virtual, actually. I mean, in Jetson JetBot, Jetson Nano, it is actual Python that talks to hardware and moves the wheels and everything.
Yes, yeah, I haven't had the pleasure yet of doing that. I gotta do that with I bought one of those, the Jetson Nanobot too, or I only have the board, but yeah, I want to try that. Thank you for mentioning that.
Okay,
Great.
Thank you, Jim.
Yeah, any other questions, concerns? So we'll meet again in 2 weeks, and we'll have this this new open format. I just ask people just write up, write in the chat if you're going to present, and that'll just let us organize a little, and hopefully Ben will be back.
Yeah.
Where is Ben anyway?
Oh, he's had an injury, I guess. I mean, I don't know if I should. But
yeah, I know about it. You told me about it. Like, is he getting some medical attention or something, Jim?
Yeah. So he's getting attention to that, and he's getting better.
Okay.
It was in the chat there, so.
Mm-hmm.
But yeah, hopefully things will be okay. That's the first I had heard of it.
Yeah, he's doing a lot better. They should be letting him out, releasing him tomorrow. It's just the timing wasn't right. He wasn't able to make it tonight. But yeah, he's doing much better.
Okay.
Oh, that's good.
Yeah, he hurt his foot anyway.
Yeah, he hurt his foot. So yeah, so people don't worry and think that it's COVID or something like that. He hurt his foot. He had to have something done to it. So
yeah,
he's doing better.
Yeah. All right.
Well, thank you, everybody.
All right. Thanks.
Thanks for hosting.
All righty.
Alan.
See you guys later.
See ya.
Bye.